All right, picture this. You've just been called in for a high-stakes rescue mission. Sitting right there on the desk is a locked, impenetrable black box, a Cisco router. Maybe it's fresh out of the box, or maybe it's some legacy device with a totally lost password that's completely holding up your network. We all know Cisco equipment is the absolute backbone of the networking world, right? And mastering it is a fundamental rite of passage, especially if you're grinding through your CCNA. So in this explainer, we're going to learn exactly how to break into that physical box, take total control of it, and master its core functions from the ground up.
Okay, let's dive right into our roadmap for today. We'll start with connection and memory, then move into the boot sequence, navigating the CLI, the big one, password recovery, and finally, backup and security.
So, phase 1, connection and memory.
Before we can hack or configure anything, we really need to understand the physical hardware sitting right in front of us. Our physical target today is the Cisco 2801 series router. When this machine is fresh out of the carton or totally disconnected from your network, it's basically an isolated island. You can't just access it over the internet or pull up a web browser. We have to establish a direct physical bridge to even start talking to it.
And that vital physical bridge is the legendary blue serial console cable. Honestly, to talk to this machine when it's completely unconfigured, you've got no other choice. You literally have to plug this blue cable directly into the physical console port on the back panel and the other end into your machine. That is our direct line right into the router's brain. Once you're physically connected, you'll need terminal emulation software, something like PuTTY, to translate your keystrokes. You absolutely need to use these exact serial settings: 9600 bits per second, 8 data bits, no parity, 1 stop bit, and no flow control. But keep this quick hacker tip in mind. If someone previously messed with the configuration register, that 9600 speed might just spit out complete gibberish on your screen. If that happens, hey, don't panic. Just try bumping it to 19200 and see if it clears up. Now, what's really interesting here is how the router's internal architecture kind of mirrors human anatomy. There are 4 distinct memory types. ROM is like its basic instinct. It holds the minimal code, the post, and bootstrap, literally just enough to wake the system up. Then there's flash memory. That acts as long-term knowledge, storing the heavy operating system, the actual iOS image. Next up is NVRAM, which is basically the subconscious memory, holding your saved startup configuration. And finally, RAM. That's the active working memory, where the router does all of its real-time thinking. Which brings us to an absolutely crucial networking fundamental. There is a massive critical difference between the startup config and the running config. The startup config is saved safely in the NVRAM as simple ASCII text. It survives a power outage. But the running config? That lives in the active RAM in binary format. It's what the router is doing right this exact second. If you pull the power plug without saving, that RAM is wiped totally clean, and your active running config is just gone forever.
All right, moving on to phase 2, the boot sequence.
Now that we know the anatomy, let's watch how its brain actually wakes up when we flip that power switch. This flowchart brilliantly illustrates the highly logical, step-by-step process of the machine coming to life. Every single time a Cisco router powers on, it follows this exact path without fail. It happens just like a strict recipe in 3 steps. Step 1, the ROM kicks in and launches the bootstrap program to test the hardware. Step 2, the router looks into the flash memory, grabs that heavy iOS operating system and loads it straight into the active RAM. Step 3, it checks the NVRAM for that save startup config. If it's there, it copies it into the RAM to become the running config. But if that NVRAM is completely empty, well, the router just throws you directly into a setup wizard to start from scratch. Let's jump to phase 3. Navigating the CLI. Okay, we're physically connected, the router has booted up, and we are finally in. Now we just need to learn how to speak its language. We start at the very bottom of the hierarchy, in user exeg mode. You can spot it by this simple greater than symbol at the prompt. In this default mode, you're basically just a guest. You can look around at some very limited basic info, but you absolutely cannot configure, touch, or break anything. It is strictly read-only. Let's move up and see how this builds. By typing the magic word enable, we elevate our access to privileged exec mode, which you'll see as the hashtag prompt. Boom. This gives us the keys to the castle. We now have access to highly detailed monitoring and every single command that doesn't actively change the router's global settings. From there, we can use the configure terminal command to dive even deeper into global configuration mode. Before we get to the real hacking, here's a quick pro tip for you. The CLI actually wants to help you. If you ever get stuck, just type a question mark, and the system will list every available command for your current mode. Even better, you can hit the tab key to autocomplete commands. Like if you type int f0/1, the router knows you mean interface fast Ethernet 0/1. And if you make a typo, the CLI will even point a helpful little arrow directly at the exact character where it got confused. All right, phase 4, password recovery. Let's shift into high gear here, because this is the high-stakes ordeal. You've been called in, the router is completely locked, and literally nobody knows the passwords. It's time to break in. The mission parameters are clear. We cannot just reset the device to factory defaults because we desperately need to save the intricate configuration that's already living on there. Our only option is to bypass the standard security sequence entirely by accessing the low-level ROM monitor or ROM mon mode. Here's exactly how we execute the heist. Step 1, pull the power. Reboot the router, and within the first 60 seconds, rapidly hit Control Pause or Break on your keyboard. This violently interrupts the boot sequence and drops you into the raw ROM monitor. Step 2, type the magic bypass code, confrag0x2142. This explicitly tells the router's brain to completely ignore the NVRAM on its next boot. Step 3, just type reset. The router reboots, you skip the setup wizard by hitting Ctrl+C, and boom, it asks for absolutely no password. It looks completely empty, but don't panic. The old configuration is still hiding safely in the NVRAM. So we type enable to get full privilege, then we type copy startup config running config. Suddenly, all those old settings are loaded right into the active RAM, giving us full access to simply overwrite those locked passwords using our own enable secret command. We are officially in control. So, the absolutely crucial point here is the restoration step. We just changed the configuration register to bypass memory, right? Well, if we don't change it back, the router will wake up with total amnesia every single time it loses power. You must go into configuration mode, type config-register 0x2102, exit, and then critically save your new setup by copying the running config back to the startup config. The heist is complete and the device is totally stable. Which brings us to our final phase, backup and security. Now that we have total control of the hardware, it's time to lock it down so no one else can pull this same trick on our network. First rule of securing your newly rescued router, always use enable secret, never enable password. The older enable password command stores your password in plain text or with incredibly weak encryption in the config file. Enable secret is the modern standard because it heavily encrypts your password using a strong MD5 hash. And hey, if both are configured somehow, the system will always prioritize the secret. Finally, we need to lock the very physical front door we just came through, the console port. By entering line configuration mode with line console 0, setting a strong password, and enforcing the login command, we guarantee that even if someone sneaks into the server room with their own blue serial cable, they'll be stopped dead in their tracks before they even reach user exec mode. And you can do the exact same thing for remote access using the virtual terminal lines. So, what does this all mean for you in the real world? Well, if you discovered an unknown rogue router plugged directly into your corporate network today, would you have the confidence to physically connect to it and take control before it caused massive damage? Understanding these core Cisco concepts isn't just about passing a CCNA exam. It's about having the raw capability to secure, configure, and rescue your vital infrastructure. Thanks for joining me on this explainer. Keep practicing, stay curious, and keep those networks secure.